Welcome back. In this video, we'll look at example 7. So one thing neat about this example is that we're not looking at an indefinite integral, we are looking at a definite integral. So we need to compute a number in the end with this problem. All right, but similarly, we're using integration by substitution. So let's follow those steps. So we first need to find a u. So we need to let u equal something. So we want to look at our function and see if we can identify sort of an inside function to represent u and see if we can find the derivative of that inside function. Well, if this inside of e, we had u, that would be really convenient. So let's try that. So let's let u equal negative x cubed. So then what would du have to be? Well, derivative of u with respect to x then would have to be negative 3x squared. So we can move the x over to the other side, and we can ask ourselves if we see this du appearing in our integral. Well, it's looking good. I see an x squared and a dx, but I don't see a negative 3. So what I'm going to have to do is divide by negative 3 when substitute in a du. So I'm going to let u equal this negative x cubed. And I'm going to have du negative 3 substitute in for x squared dx. So again, just to highlight those different colors. So I have my u being negative x cubed that we're going to substitute in. Then we're going to have our du over negative 3 be x squared dx. Okay, so now let's go for it. So actually one comment I need to say is that this 2 and this 0, those are representing what x need to be. So I'm going to make that really clear by writing x equals. So this is equal to the integral of x equals 0 to x equals 2 of e to the u du over negative 3. All right, so this we can definitely work with. So this is equal to negative 1/3 the integral from x equals 0 to x equals 2 e to the u du. Okay, so a couple things here. I don't like having x's in the integral when we're looking at just u's. So how can we fix this? Well, we can look back at what we substitute in for u and compute if x is equal to 0, what would u be here? So I'm going to write that out. So if x is equal to 0, then we have u is equal to negative 0 cubed, which would be 0 also. And if x equals 2, that upper bound here, then u would equal to negative 2 cubed, which would be equal to negative 8. So what I can do at this point is rather than have to keep track of what x is, I can just say u goes from 0 to u goes from negative 8. So I do want to say that we don't have to make this substitution yet. We can make it later on, but I just like to change it now so that we can just be working in the u land. But I'll let you know when you could also substitute that in. Okay, but better to be mindful of it earlier on. Okay, so then at this point, we have, just to clean things up, negative 1/3 the integral from u equals 0 to u equals negative 8 of e to the u du. So now, no big deal. We need an antiderivative of e to the u, which is just going to be e to the u. So this becomes negative 1/3 times e to the u evaluated at u equals 0 and u equals negative 8. All right, not bad. So now I'm just going to evaluate at each point and subtract. So even though negative 8 is smaller than 0, I always start at this upper bound and then subtract what I evaluate at the lower bound. So this is going to be negative 1/3, using a lot of parentheses here, e to the negative 8 minus e to the 0, which is going to be equal to negative 1/3 e to the negative 8 minus 1. Because base to 0 is always 1. So it's fine to leave your answer like that. If you want to multiply that -3 1/3 in, you can do that too. So negative e to the -8/3 plus 1/3. So you can also multiply it out, but that would be our final answer. So what I told you about the x's and u's, I did that right away because I like having my integral with just u's. I like to get out of my x world, go into my u world, and just finish out the integral. That feels cleaner to me. You'll see other people, or if your preference is to continue using that x, you can do that. So we could instead here say continue to have x. So I'm going to erase throughout. There's just another option. So we could say x equals 0, x equals 2, x equals 0, x equals 2. And then now at this point, what you could choose to do is sub back in for u. So it's kind of like an alternative way to finish. So now we can say, well, this is equal to -1/3 e to the, well, u is -x cubed, so -x cubed, evaluated at x equals 0 and x equals 2. So notice how we get the same thing in the end. Because we're going to evaluate when x equals 2, we get a -8 in the exponent at first. Then we evaluate when x equals 0, which will get a 0 in the exponent. So it'll come out to, that should be a -1/3. It'll come out to the same solution in the end. Awesome. Awesome work, everyone. And you'll meet me in the next videos for some more examples.